Welcome back to Monroe Live, everybody. Today we have Scott Hildreth with us. He has over 30 years of experience doing body structure and hardcore design work. You worked at McDonnell Douglas Aircraft?
Yeah, a long time ago.
As well as AM General. You were at Chrysler for a while doing durability stuff.
A couple times, yeah.
But you have a ton of experience, so we want to look at this top cover, compare and contrast it to what we saw on the old Model Y, and then maybe you can make some sense of some of their decisions. So the first thing we notice is the whole top cover, minus the penthouse, looks to be powder coated. So you want to explain why they'd want to do that, or why it's a bad idea?
Well, yeah, it's actually not really clear to me why they would do it over the whole cover. You know, obviously with the new structural pack, right? If you see here along the edges where they now have to seal this to the body. In the previous video, you know, you saw the big opening, and you know, you can't have any water intrusion or anything else. Now, I do have some past experience from a long time ago, knowing that these kinds of materials don't want to stick to certain types of surfaces, and I'm theorizing the reason that we have this kind of either like a clear powder coat or something, almost looks like a clear coat like you would have on your car, but is really probably more to get this sealing material to stick properly to the top cover. Now, for some reason, you know, they've extended it and kind of done the whole thing. It looks really nice. I'm not sure process-wise what's driven them to do that. Maybe it's just easier to make sure they've got the right coverage and everything to just coat all the parts, because obviously this is built, it appears like the whole top cover is built as a sub-assembly, probably then, you know, powder coated and then delivered to the plant in that form. But really kind of interesting. It makes for a nice look, I'll say that for sure.
Now let's start from the top down. So these seat risers are for the Model Y because the position of the occupant is higher than the sedan, the Model 3. On our previous Model Y and Model 3 packs, the seat risers were bolt-on the Model Y to raise the seats up because they didn't exist on the Model 3. Now, these are from the Model Y from 2020. Now, Scott and I were looking at this before we started filming. It's a completely different manufacturing process. So first of all, they're not physically screwed into these cross-car structural pieces like they were on the 2020 Model Y. They're spot welded, and you can see 1, 2, 3, 4, 5 spot welds, 1, 2, 3, 4, 5 spot welds on each side of the ear for the rear, and you have 4 in the front and 4 in the front, and that repeats itself throughout. So you have 5 on each rear foot, 4 on each front foot, but then there's an additional MIG weld. Is that right, Scott? Some MIG weld?
Yeah, on the back of the inboard riser.
Now, explain why you'd want a MIG weld there.
So what I'm assuming, like what we have here in this situation, right? So you have the seats mounting here. Well, there are federal requirements, you know, in terms of how much load that seat has to be able to carry, and that load has to go down into the body, right? So when you can imagine if I'm sitting here in the passenger seat and I latch my seat belt down, well, that is actually connected to the seat, and then that seat is actually bolted down here. So you have essentially 6,000 pounds of load on each of these seats when they're doing this FMVSS test, and all that load going down in here, and it's really kind of wanting to rotate this structure and kind of wanting to put all these welds in peel. So I would imagine they had a situation, maybe they couldn't get enough spot welds in here, and we're having a situation where they just needed to bolster the strength here and prevent any sort of peeling condition, you know, here on the most inboard side of the driver and the passenger area.
Yeah, and on the previous Model Y, they used a different type of construction for these seat risers. So if you notice this seat riser, you got 1, 2, 3,
There's
4
4 identical parts.
They look similar to near identical, but yeah, that was what they did on this as well. But we noticed that they used this awkward tube that essentially is bent over, and then these look to me like it's like a flow drill process, but without the threads. Essentially, you're welding the little ring,
yeah,
where you come in and it's spinning and it just punches through, heats up, and welds together. This is kind of an awkward design. The thickness on these pieces is much thicker than this thin clamshell. And then the bracing underneath is larger on this one. They went to a U bracing. There's less pieces here. I think we counted 1, 2, 3, 4, 5 if you count
the weld nuts.
Weld nuts. Here we had 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so 9 parts.
Yeah,
so
it's a big part reduction, and it's just a much more elegant design, right? That looks like brute force, and this looks like a much more engineered product right here, right?
So I'd say a little bit.
And we don't have them off, but having picked this up, I'm going to assume that this is actually also a fair bit lighter as well.
And this poor guy right here is heavy. It looks like some sort of alien dreadnought. Look at it. Very thick, complex design. Once again, they've gone to a less complex design, partly because the mounting provisions for the center console have changed. Because that center console, if you remember in the first video, we might show a little B-roll of it, slides forward and back to accommodate the ability for the pack to deck with the center console hanging out there, slide forward for assembly. So once again, even though this Model Y is only 2.5 years newer than the original Model Ys that were launched in 2020, see drastic changes throughout. And Scott, you wanted to talk a little bit about why they bolstered this section for the seats. So you have structure for the seats to mount. That's important.
Correct. Yeah.
But is there some crash tests you want to talk about?
Right. So you have some FMVSS requirements that all the vehicles have to meet. You know, in this case, in the side impact, one of those things is a side pole impact, where the vehicle is actually impacted into a pole. And that's essentially aligned with the front occupants of the vehicle. So if you were to look down here, you know, Eric can kind of zoom down there. What you see is in the middle of the pack here, we have a large tailor welded blank that's a thicker part here in the middle of the pack. And then on the outboard sides, we also have another doubler that's added here to add additional strength. I'm theorizing for that event, most certainly to help the structure of the overall pack. Additionally, when we're talking about the tailor welded blanks, you know, we have another section up here in the front, which once we get it off, we'll kind of check the thickness of everything, but the kind of the fingernail test seems to feel like we have a thicker section up here, which kind of makes sense. You know, you've got the full frontal impact, you've got SORB, and there's some offset requirements for impact as well. So probably the front of this pack is also, you know, doing a little duty up there too in those events.
Scott, you said SORB. We try and define all of our acronyms. What's SORB again?
Small overlap rigid barrier test. That's an IIHS test.
Yeah. There's something unique that we notice about this pack that I think you won't find if you buy a future vehicle. Notice this witness mark right here. So Scott and I found this the other day after we shot our video. There is a witness mark from where the bead for the seal used to run. It's like they peeled it off and they had the path wrong. So see that path right here? And we went and looked underneath the body and noticed that if it took this path, it wouldn't actually seal. It needed to seal in this path.
Yeah, it's like they programmed the wrong curvature. It should have been more, you know, this way, and it went out instead of in, and they fixed that problem on this one. This is obviously an early pack.
And then now we're going to move to the back penthouse. And it's quite different from the old penthouse. I believe this is from the Model Y or the Model 3. But they used to have a smaller amount of access, and the cover for the battery came up and actually included a portion of this penthouse. So look at how much larger that is. And it's much simpler. We were joking that this looks like an oil pan from a 1950s or 1960s car. So if you're out there and you're stamping deep draw oil pans, there is still life for you making penthouses for electric vehicles. Now, we're going to dedicate an entire episode to what has changed underneath the penthouse. This episode is more dedicated to structure, and the first thing we notice is how they changed the seal. They used to have this very robust bulb seal. Not sure how they put this on. I mean, you can see it's like it's a wickedly strong bulb seal. And now they have changed to this softer jelly type seal. Antonio, can you pull this off? But the interface of the penthouse to the actual structure of the pack is very, very secure. And actually, I'm going to grab that. It's over there. They have this extra doubler right here on the outside. You can see it ends right here. My finger's hitting the edge of it. And the edge peels up. And then the other edge peels down, which is part of the deep draw. A very expensive laser welding process. So I'm not sure if they would have done spot welding, they could have had some deformation here. Scott, you want to talk about that?
Well, certainly, you're probably right there, right? So that process is probably helping them maintain that nice, clean, flat surface that they have to seal against. In addition, obviously, there's a structural reason that they've added this doubler over this whole thing, right? So I guess, once again, just making an assumption that, you know, with this being more of a structural pack, maybe more of a stressed member back here, they found that in that area, maybe to maintain sealing, they need additional strength on the cover. Not exactly sure why, but obviously it's there for a reason. It's there for strength, and it could simply be for sealing, but once again, maybe because of this being a more structural member of the car now, maybe they found that simply to maintain the sealing, they need additional strength around the perimeter of that cover. So it's kind of interesting.
On our older Model 3s and Model Ys, there was a large black, I think stamped steel or stamped aluminum panel that went underneath all of these penthouse components. Now there's a new carrier. If you see this black plastic right here, probably polypropylene or nylon or something, it goes all the way to the edge, and it has stanchions that hold, here's your low voltage supply right here from your DC to DC converter. All the way over here, it's holding the contactors for your high voltage charging. This large plastic injection molding piece is now the carrier for all the components. So this has been the biggest change I've seen under what we're calling the penthouse. Some of the locations of the flow of the cooling have changed, and this is the first time we've seen a Model Y or Model 3 using something besides PA12 for the lines. So these were PA12 back on the old Model 3 and Model Ys. They've changed to something, it feels more like HDPE to me, but they're using these Caillou clamps. Those Caillou clamps, yeah. But we're going to dig a lot deeper into this once we have a chance to disconnect all of the high voltage lines, and we can remove the large charge module and DC to DC converter. But this is the first look at that. Scott, is there anything else you want to say about the structure of the pack? Have you knocked on it? Does it feel like a solid brick?
Yeah, it feels, I mean, we've been knocking around on it, right? And it, you know, I'll be interested to see how easily we get the cover off. I mean, given that sounds pretty well packed under there. So that'll be pretty interesting to kind of see here in the next episode what we find underneath of there, and really how things are bonded, what the structure looks like. Because overall, you know, it doesn't look that much different than one of their other packs. It's not like what we would see on a Mach-E or the ID4 with the big packs with the big extrusions, and you know, it still looks like a Tesla battery pack, right? So that's, I think, to me, that's one of the really interesting things when they mention structural pack, that it still really looks like one of their packs.
Did you expect to see more structure?
I did kind of expect to see something more, so that's, I'm curious to see, you know, what's in it. I know there's some pictures out there and stuff, but I know we've done, from some past work we've done, you know, they may not relied on the pack quite as much as some of the other manufacturers have. The other interesting thing to me, and I'm certainly, it's not an area that I'm that familiar with, but in this, with this and in the way they're doing it and executing it and decking it into the vehicle, I mean, they had to deck the pack anyway, right? In the old process, they still decked it. Now they just deck it into a big hole with the seats and stuff on it. But the interesting thing to me is that you now have the occupants sitting on the top cover of a battery. There's no separation like anybody else's vehicle, right? But in the past, there was a floor pan, there was something there that separated the occupants from the top of the actual battery pack. I'm not saying that means anything. I don't really know.
So,
because
based on that, the fact that they're using 4680 cells and they can control the orientation, I'm guessing they're all pointed down. And we can have Antonio confirm that, or we'll confirm that when we get the the cover off.
But yeah,
that's
still
critical.
Interesting that, you know, that the occupants would be sitting on it. You know, traditional automotive manufacturers are, I don't want to say risk averse is not the right, it's kind of risk averse, right? They're going to take risk in little chunks, and whether or not they'll go to the same place and willing to do the same thing. You know, time will tell, obviously. It'll be a generation down the road for all those guys before they would probably attempt something like that. But
all right, so Scott, I think that wraps up our initial assessment of what we see with the seats and carpet off. And I want to remind our viewers of something. You may be wondering, like, man, Monroe is just giving away all of this insight. This is basic benchmarking stuff that we're giving away. Our team of nearly 100 employees, creates some phenomenal reports with not only insights, but full cost analysis. So while Scott and I are going over the macro level differences between these seat rises, we have a team dedicated to actually quantifying the impact of that in our reports. So we've sold dozens and dozens of Model Y reports already, all the way around the world, from suppliers to OEMs. We are going to be selling a supplemental report for this Model Y. So all of the changes that we're seeing, we're going to quantify them and sell a supplemental report for far less than the full cost of the Model Y. So if you're out here watching this video and you know your organization already purchased our full Model Y from 2020, reach out to sales@leandesign.com and get in line for our supplemental report, because we're going to quantify everything that you're seeing in these videos. So once again, thanks for watching Monroe Live, and we have probably 4 or 5 more videos coming on this vehicle. Thanks.